This segment of our course covers the reassembly procedures for a cooling fan. We will put the fan back together and install it on the drive shaft. First, we'll position the hub assembly for installation of the blades. In short, place it on a work table or bench with sufficient clearance on all sides to install the blades. Now select the first blade and retention socket to be reinstalled in the hub. Apply a coating of corrosion resistor to the blade shank. It's considered good practice to apply this material to the mating surfaces of the socket as well. Your instructor can show you the corrosion resistor now in use at your plant. After you have applied the coating, check the match marks on the socket and blade shank against the corresponding marks on the hub assembly. It's important that the blade be reinstalled in the same position from which it was removed. Holding the retention socket halves in position on the blade shank, slide them into position between the hub plates. You may find it necessary to pry the hub plates apart to allow entry of the socket, as shown here. Notice that he's using a piece of wood for this purpose. Wood is used to prevent damage to the protective coating on the hub plates. Align the bolt holes in the retention socket with those in the hub plates. Then install the cap screws through the hub plates and sockets with the heads on the top as shown. Don't forget to apply your rust resistor to these bolts before they are installed. With the blade in place, turn it in the socket until the flat side of the blade is positioned on the downwind or discharge side of the fan. In this case, the top of the fan is the discharge side. Now place a support under the tip of the fan blade, like this, to hold this blade in position until it is tightened securely in place. Then install the washers and nuts loosely on the retention socket bolts. Grip the end of the blade firmly with both hands and pull it away from the hub assembly until all slack between the shank flange and the retention socket has been taken up. This is done to ensure that all blades are in the same position. Now tighten the nuts on the retention socket bolts tight enough to support the blade, yet loose enough so that you can still turn the blade shank in the socket. This is necessary since we will need to adjust the pitch of the blade later. You would then repeat the procedure we have just shown you on the opposite blade in the fan, installing it in the hub. Tighten the cap screws in the tapered bushing, ensuring a firm seat in the tapered bore of the hub. Once that's done, position the hub assembly and two blades on a static balance block. Then check them for balance. If the assembly does not balance properly, refer to the manufacturer's manual for the fan to find out the recommended method of balancing the assembly. This may call for adding small weights to the light side of the assembly, or some other method. After the fan is in balance, install two more blades opposite each other, as we demonstrated a few moments ago. After the next pair of blades is installed in the hub, place the assembly back on the balancer and check it again. Continue this procedure until all of the blades have been reinstalled and balanced. A note of caution: don't attempt balancing in wind or even a light breeze. You'll soon find that it's impossible to do accurately. The next phase of reassembly is to install the hub and fan assembly on the drive shaft. Before doing this, the workman inspects the shaft very carefully to ensure that it is clean and free of burrs. Then check to be sure that the support spacer is in place on the drive shaft, as being pointed out here. Take a close look at the tapered bushing in the hub to to ensure that it is clean and free of burrs. Check to ensure that the key fits properly in the tapered bushing keyway. Compare the measurements of the shaft and key, as shown here, against the ID of the tapered bushing and keyway, measured like this, to make sure that you will have the required clearance fit. The manufacturer or your instructor can fill you in on the required clearance on the fan you'll be working with during this course. Now coat the shaft and the bore of the tapered bushing with rust resistor, as you did earlier on the other parts. Loosen the cap screws in the tapered bushing and back them out about 1/4 of an inch. Then break the bushing loose in the hub with the 2 jack bolts, as you did earlier during the disassembly of the fan. To make the assembly easier, the workman now inserts a wedge in the split of the tapered bushing and uses it to spread the bushing slightly, increasing the inside diameter. This is done to create additional clearance, allowing the bushing to slide easily over the drive shaft. Next, the workman removes the 2 jack bolts from the bushing and replaces them with the eye bolts. He then attaches 2 slings of equal length to the eye bolts and to a hoist, as before. Now, using the hoist, he positions the hub and fan assembly over the drive shaft and starts the assembly on the shaft. Then, removing the wedge, he lowers the assembly carefully onto the shaft until the bottom of the tapered bushing is resting on the support spacer, as we showed you earlier. When the assembly is seated, he removes the slings from the eye bolts and replaces the eye bolts with the cap screw plugs. Tighten the cap screws in the tapered bushing with a torque wrench, using the pressure specified by the manufacturer of the fan. Be sure to use the crossover method to ensure an even seat between the bushing and the tapered bore of the hub. The final step in reassembly is to tighten the 2 cap screws in the jack bolt holes of the bushing. They will be used to seal the 2 holes until they're needed again during the next repair session. Don't forget to coat all threads with a rust resistor. That concludes the basic reassembly of our cooling fan. We'll be back to show you the final adjustments after you complete exercise number 3 in your workbook. The final segment of our course deals with the adjustments of the blades once the fan has been reassembled. This includes setting the pitch of the blades, checking the tip clearance, and checking the tracking of the blades, as we did earlier before disassembly. The first step, and a very important one, is to ensure that the fan assembly is level. It's impossible to get a true reading of blade pitch unless the entire assembly is level to begin with. Next, find out what the desired pitch is for the blades of your fan. This information may be obtained from several different sources, depending on the procedure at your plant. It will be listed in the manual published by the manufacturer of the fan. On some fans, it is often stenciled on the blades. And in some cases, the pitch may be determined according to your plant engineering requirements. If in doubt, ask your instructor or your supervisor. They'll be happy to help you out. Once you've determined what the required pitch is, obtain a bevel protractor and set it at the angle you want. Now, refer to the manufacturer's manual again and find the location on the blade at which the protractor must be positioned. The spot has sometimes been referred to as the pitching boss. In any event, the position will be specified by the manufacturer. With the protractor in position, rotate the blade on its retention socket until you have obtained the desired degree of pitch. Be very careful not to tilt the blade in the wrong direction. In short, make sure the blade is pitched in the direction of rotation, as shown here. Once you have the blade adjusted, tighten the bolts in the retention socket enough to hold it in position. Then repeat the same steps for each of the other blades of the fan. Make absolutely certain that your protractor is positioned in the identical spot on each blade. And here's something else you must remember. Check the pitch of each blade at the same position in the rotation of the fan. Here's what we mean. The workman has picked a specific spot at which he will check and adjust the pitch of the blades. He's standing on it right now. When he checks the next blade, he will move it to the position of the blade he is now checking. In short, don't move to the next blade to check it. Move the next blade to you. This is done to prevent possible deviations due to the position of the blade in the rotation of the fan. After you've set each of the blades, use a torque wrench to tighten the bolts in each of the retention sockets. Again, using the crossover method. The bolts should be tightened only from the nut side. This means you would use the torque wrench on the bottom, not as shown here, on the top of the cap screw. The torque required is supplied by the manufacturer in his manual. When all the bolts have been tightened satisfactorily, recheck the pitch angle on each blade with the protractor to make sure that it is not changed when you secured the retention socket bolts. The remaining 2 checks and adjustments are normally completed after the fan has been reinstalled in its unit. Therefore, we will assume that this fan has been installed in a cooling tower, and that this wall is the shroud which surrounds it. We'll use this facsimile of a shroud in the presentation, since we can better illustrate the 2 checks this way than by actual installation in a cooling tower. The checks themselves will be identical. First, we will pick one blade and rotate it through a full 360 degrees within our shroud. We do this to determine whether or not the shroud is out of round. This is done by marking the points on the shroud at which the clearance between the wall and the blade tip is closest and farthest. In short, we mark the spots at which the blade tip is closest to the wall and farthest from the wall. Now measure the tip clearance between the blade tip and the shroud wall at the points you marked a moment ago. The minimum distance should normally be between a 1/2 inch and 3/4 of an inch, or as specified by the manufacturer in his manual on the fan. Once you have completed the measurements of the tip clearance for the first blade, repeat the procedure for each of the remaining blades on the fan. However, the only measurements which must be taken on the rest of the blades is the minimum tip clearance, not the maximum clearance. If the tip clearances do not measure up to specifications, refer to the manufacturer's manual or your supervisor for the action to be taken. This may entail corrective work on the shroud. The final check to be made is the same as that completed before disassembly of the fan at the beginning of the course. You must recheck the blades for tracking. As you may remember, you must position a pencil on the top of the blade at the trailing edge like this. Make sure that the tip of the pencil is in contact with the wall of the shroud, and that it is parallel with the axis of the blade. Now, gripping the pencil tightly, rotate the blade enough so that the pencil will scribe a short line on the wall of the shroud. Then match mark the blade with the line for reference purposes. Repeat these steps for each of the remaining blades in the fan, making the marks at the same point on the inside of the shroud, and match marking each of them. The deviations between the marks should not exceed the specifications set forth by the manufacturer. If the marks are erratic, as shown here, You will simply need to locate the problem behind the deviation of the blade being pointed out. As you can see, most of the blades are close to being in line, except one. The difficulty is probably in the retention socket of the blade. Here is another example you may encounter when checking tracking. By looking very closely, you can see that each succeeding blade has formed a wave pattern. This indicates that the fan assembly is not square with the drive shaft. The difficulty with this fan would probably be in the fit of the tapered bushing in the hub. Whatever the problem, take the necessary corrective action to bring the tracking within specifications. Then recheck the entire fan one more time to ensure that all steps have been completed. Once that is done, you would return the fan to service in accordance with the procedures recommended at your plant. Don't forget to clean up your tools and equipment. That completes our course on the repair of a cooling fan. As you have seen, the methods and procedures are not that difficult. However, it is essential that you follow them very closely and refer to the manufacturer's manual or your plant's engineering requirements for the information you need. Remember that a poorly reassembled and tested fan could throw a blade through the side of the shroud. Don't take chances. For safety's sake, pay very close attention at all times. We have some questions for you now on the adjustments required on cooling fans. You'll find them in exercise number 4 in your workbook.